Hello, and thank you for attending this virtual poster session. We're very excited to present our latest research on deep learning in a neuroscience setting. We're a team of researchers at both Columbia and the New York State Psychiatric Institute. I'm Maxime Tchibozo. I'm an alumni from the Data Science Institute and a part-time researcher at the New York State Psychiatric Institute. My collaborators are Zijing Wang, who is also from the DSI, Donggeun Kim from Industrial Engineering and Operations Research, and Professor Xiaofu He, who is a professor of machine learning at the Data Science Institute and also a researcher at the New York State Psychiatric Institute. Our research focuses on emotional brain state classification. Now, brain state classification aims to recognize brain activity patterns in fMRI data, and emotional brain state classification focuses on emotions, on regions of the brain which are specific to emotion experiments. Brain state classification is a very important tool for psychiatric diagnosis of disorders such as major depressive disorder, and it's also very important for brain-computer interfaces. We performed an experiment at the New York State Psychiatric Institute where we measured the brain activity of a group of subjects, including 10 subjects with major depressive disorder and 12 subjects who were simply healthy control subjects. We measured their brain activity in the format of fMRI scans. And this activity was measured during a specific experiment in which we showed images to subjects. So a subject would view either a negative image or a neutral image from the International Effective Picture System. And the task we are trying to perform is to predict the label that the patient is viewing, that the subject is viewing, using only the subject's fMRI data. So traditionally, this is a task that's performed with statistical classifiers. And the issue with the traditional approach is that fMRI data needs a lot of preprocessing, and these specific classifiers require us to extract features from the fMRI data, which can be very complex in the case of emotion tasks. We use instead a 3D residual neural network. So here is the architecture of the ResNet. Traditionally, the ResNet is a deep learning classifier for 2D images, and we adapt it to 3 dimensions by using 3D convolution kernels instead of 2-dimensional kernels. And the specificity of the residual neural network is that it has skip connections which can pass over entire blocks of convolution aids. We feed in 64 by 64 by 44 fMRI scans, and our data set consists of 3,048 fMRI scans, which we split into a training, validation, and testing sets, with 80% for training and validation, 20% for testing, and then later 80% of training and validation just for training, and then 20% for validation. The data set that's used for testing is balanced, meaning that there are as many classes of negative images as there are classes of neutral images. And the accuracy of the classifier is 78% with a standard deviation of 4.4. And the F1 score of the classifier is 0.816. This is in line with other machine learning classifiers such as gradient boosting, support vector machines, and multi-layer perceptrons. We see from these loss and accuracy plots that there is some significant overfitting for this model, and we believe that the cause for this is the low amount of data. So here we have 3,000 images, and typically for deep learning models, we would want tens of thousands, if not hundreds of thousands of labeled data. This brings us to the conclusion of our work. We found the 3D ResNet to be a very promising candidate for emotional brain state classification, and we would like to further this research by using a larger data set from the Human Brain Connectome project, and also exploring different architectures, notably of efficient nets, which are like ResNets, but using orders of magnitude of fewer parameters. We want to thank the New York State Psychiatric Institute and Columbia Medical Center for helping us in this research, and we want to thank you, the viewer, for watching this presentation.